I'm gonna record it in the cloud. So I already uploaded the first part of the lecture. So I was kind of like trying to do too much today, but and last class, but I just realized that our lecture, this normal distribution, which is chapter number 6. So the PowerPoints also include chapter number 7. So, and in total, we have 46 slides. So it's gonna be not that difficult. So we already have covered a lot. So we are gonna go back to this and probably, so we still have, so today is the 19. The 22nd. Or no. So the next exam, I'm getting confused. So the next exam for this class is gonna be on November 1st, right? So the next set of assignments are gonna be due on November 1st. So we have this class on the 19th, we have one more class on the 21st, then we have 2 more classes, the 26th and the 28th, and then we have the test, okay? So we have plenty of time to complete these assignments. So I'm gonna take it easy. I'm gonna go back and forth so we can do this without any problem. So did I start? Yes, I start recording. So once again, please keep in mind that normal distribution and central limit theorems are due on November 1st. So we have plenty of time to go through the slides. And if you have questions, let me know. So there are still many students that didn't complete the assignments on timely manner. So please, if you have any questions, if you want to make it up, contact me as soon as possible. So there are so many assignments that are, I mean, all the assignments are very important. So the Excel assignments, the tests, the exercises. So if you have missed many of them, you probably are gonna fail. So I don't want people to fail the class. So please contact me as soon as possible, and and probably we can make some arrangements. So so now we're gonna go to the class. So so we have been doing this standard normal distribution. We mentioned that this is one of the most important, that almost all the disciplines use the standard normal distribution. This is a symmetric distribution. The mean is in the middle, the median is in the middle, the mode is in the middle. So we have this standard normal distribution of a random variable. So here our random variable follows a normal distribution with a mean and a standard deviation, mean mu and a standard deviation sigma. So we are going to measure the area under the curve, and we're going to be using the cumulative area. So remember, this cumulative area is going to be equal to 1. So we have some of these features of the normal distribution. So the area under the curve is 1. The 2 parameters, they can change the shape and the position of the curve. So we have so many that we're going to use one that is of special interest, that is called the normal distribution. So we learned how to compute the C-score. So in this case, we need a mu, we need a sigma, and we need the value of a random variable to compute the C-score. If we have the mu, the standard deviation, and the C-score, we can find the value of our random variable. So we can do many things here. So this, remember, this standard normal distribution, what it's gonna tell me is how far my standard deviation is from the mean, to the right or to the left. So 1 standard deviation, 1.1 standard deviation to the right, to the left. So the number that I am obtained here it's gonna convert any numerical number into standard deviations. So in some cases we are, well, not in some cases, we are standardizing values. You can have, like if you remember the case where we were analyzing the two different scores and we didn't know which one was higher or lower. So we measured that in the standard deviations and we realized that one of the guys had a lower score compared to the other, because when you are comparing different scales, you cannot make comparisons. So you have to convert them in the same scale. But also these C scores are gonna tell me the number of standard deviations to the right or to the left. So I can make well, I'm gonna use the C score as I mentioned. So the C score is the random variable minus mu divided by the standard deviation. So this is the difference between the actual value, the hypothetical value, and then divided by the degree of variation. So, so that's what we're gonna do with the C score. So once again, it's gonna give me the number of standard deviations to the right, to the left, and that's going to be very important. So we look at this case. So we have a random variable that follows a normal distribution with a mean 5 and a standard deviation 6. So we are looking for number 16. So let me just skip this because that's what we did before. So this is also very important because we are going to be following the empirical rule. So that empirical rule says that between one standard deviation, we have almost 68% of the values lie between one standard deviation to the right and one standard deviation to the left. 95 of the values lie between two standard deviations to the left and to the right, and almost 99.7 of the X values lie between -3 and +3 standard deviations. So I mentioned this is very important, 95%, because some values that are above the 95% are considered, sorry, those values that are beyond -2 and +2 standard deviations happen to be unusual. That those values that fall between -2 and +2 standard deviations are usual. So we have this little thing here. I think we passed it already. I think we passed it. So that's a little bar that says beyond 2 standard deviations, cases are unusual. Okay, so so that's very important to know. So so we were looking at the normal distribution. Oh, so before of this, let me open the Excel file. So I did this little Excel exercise for the class. So it's very simple, extremely simple. So in the first case, well, it says now we will consider several examples that illustrate the use of the C score. I copied this from a website. I don't remember the website, but I can tell you that I didn't do this, somebody did it, and I just copy and pasted it. So suppose that we know about a population of a particular breed of cats having weights that are normally distributed. So this is very important. I already know that these are normally distributed. So I can confidently use the normal distribution. So furthermore, suppose we know that the mean of the distribution is 10 pounds. So we have the 10 pounds here, and the standard deviation is 2 pounds. Consider the following questions. So what might be the C score, because that's what we want to know, of X1 equal to 13, X2 equal to 6. So what we basically have here is the following. So I'm gonna draw this little graph. So we're gonna have a normal distribution. And always forgive my drawing because it has to be symmetric. Just imagine that this is symmetric, and I am a very good person doing graphs, which I am not. So here we have the mean equal to 10. Let me go. So we have the mean equal to 10. Oh, I see. And we have sigma equal to 2, right? So the question is find the C-scores that corresponds to 13. So this is x1, that is gonna be equal to 13. And this is x2. I'm gonna put an arrow here. It's gonna be x2, which is equal to 6, right? So very clearly, my C-score here is gonna be positive. Why? Because it's to the right of my mu. And this C-score has to be negative because it's to the left. So in this case, I can compute those values. Remember, to compute these values, I guess I put the formula here. It says standardize x minus x. So you have to say equal standardize, open parentheses, you give the x, then the mean, and then the standard deviation, right? So to make the case here, so remember what we are gonna find is gonna be, so I'm gonna throw, no, hold on. So I'm gonna throw it here. What we are gonna find is basically the standard normal distribution where my mean mu is 0 and sigma is gonna be equal to 1, right? So I want to find this C-score 1 and this C-score 2, right? So I'm gonna find the values, and those values are gonna be the values that I'm gonna find using the formula for the C-score. So I'm not using the formula because I know something better. We can do this in Excel. So I'm gonna say equal standardize, open parentheses, my x is gonna be my random variable, right? So that's the first one. Then the mean is gonna be 10. Then we can see here a standard deviation is gonna be 2, right? So it's 1.5 standard deviations to the right. So this C-score basically is gonna be 1.5, right? So the second one is gonna be when x is equal to 6. So once again, I'm gonna say standardize, standardize. I should improve my, so my x is gonna be 6, my mean remains the same, and my standard deviation is gonna be this, right? So once again, when the value is located to the right, you're gonna find a positive number, so the C-score is gonna be positive. When we are on the left, the number should be negative. So we have a -2 standard deviation, right? So that makes sense. 2 and 2 is 4. So if I subtract 2 from 4 from 10, so that's gonna be the C-score. So the other case is how many pounds corresponds to the C-score. So remember, this is very clear if we want to find the X. So we have the mu, we have mu plus a standard deviation times C-score times the standard deviation, which is sigma, right? So let me make this more clear. I'm gonna use here the symbol that is mu, and this is gonna be sigma, right? So is the C-score times this. So let me put a little parenthesis. We don't get distracted with things. So that's what I'm gonna do, right? So in this case, I have the C-score that is gonna be 125. So here the question is the following. So I have where is my trunk here? I have the same graph. So that's totally. So I have the same graph. Well, in this case, what I have is the standardized, right? So I have a mu that is equal to 0. I have a sigma that is equal to 1, right? So, and I want to know the value that corresponds to this 1.25 as a C-score, right? So this is gonna be my C-score. So I want to know the number. So what it means is the following. I have my thing. So here I have my normal distribution. We go lower and lower. So I'm gonna have my mu, which is equal to 10 in this case. Sigma is gonna be equal to 2. And I want to know what is the value here, right? So what is the value that corresponds to 1.25? I don't know. That's what I want to find out, right? So in order to find this X, I need the value of mu, I need the C-score, and I need the value of my standard deviation. So all this information, I have it. So I'm gonna compute it here. I'm gonna use the formula. So this case is very simple. So I'm gonna do the following. Equal, my formula says mu, which is this one. I am gonna add, then I'm gonna multiply the C-score, that is 1.25, that multiplies 125 because this is the value of the C-score, that multiplies the standard deviation, right? So then the value that corresponds to this is gonna be, I already know this, so the value that corresponds to this is gonna be equal to 12.5, right? So that works very nicely, I guess. That works very nice because so here all I need is the C-score with all this information. But you might ask yourself, what happens if the C-score is negative? So so in this case, what I can do is the following. So just imagine that instead of being a positive number, I'm gonna modify this. Instead of being a positive number, now the C-score is a negative number, right? So instead of being a positive 125, I am wondering about the minus 1.25, right? So how does it work? So in this case, my C-score is gonna be minus 125. Well, that's not a big deal. Let's say I'm building the formula from the ground up. So all I have to do is just put a minus 125. And then we are gonna get the value. So in this case, the 1.25 C-score here corresponds to 7.5, right? I think that doesn't work. I'm too close. So it's gonna be 7.5, right? So that is gonna be the value of X, okay? So we are gonna do some other examples. I guess this is only to find the C-score, but you want the C-score because you want to know the area under the curve, right? So we were addressing this. So I use this second part. So let me go through this. So we have this, we have the empirical rule. So we were looking at the area under the curve. And remember, some of the things is that when you have a value that is less than k, this case, my random variable is less than the value I want. So that means I am measuring the area to the left. So when you see this minus less than sign, you are measuring the area to the left. When you are seeing the opposite, the plus, the greater than, so we are measuring the area to the other side, right? So that's what we know. So we can measure the area that is to the left, we can measure the area that is to the right, or we can measure the area that falls between two different variables, right? So I can measure the area under this, right? So those are the three cases that we can see when we have the C-score. I am wondering what is the area that lies to the right, sorry, to the left. If I want to know the area to the left, I can compute it also, and then the area between two different random variables. So we have the area to the left of the vertical line. So that means we are going to be measuring that area. The area to the right. So it says in order to compute, and I think I mentioned that was wrong, the area to the right. So what I have to do is subtract the area to the left from 1. Why? Because if I want to find this area, I know this area. So in order to find the area to the right, I have to subtract this area from 1. Okay. So, and to find the two areas between two different random variables or two different C-scores. So what we are going to do is we are going to find the area to the left of one of the variables, the area to the left of the second, and then we are going to subtract the smallest from the largest. We are going to see a very specific example. I just want this to be very clear. So is this clear so far? So we did a last class. I mentioned the area to the left, very easy. You just measure what in your tables, what your table or your Excel function is telling you. The area to the right, we find the area to the left and then subtract from 1. And then the area between two random variables or two C-scores is going to be the C-score of this, the C-score of this, and then subtract the smallest from the largest. That is going to be the area between two different C-scores or random variables. So we saw this case. Let me go again. So we have here in this case, let me mention this. So this is the area that is more than 65. Hold on. So let's read the case. The final exam scores in a statistics class were normally distributed with a mean of 63 and a standard deviation of 5. So find the probability that a random selected student scored more than 65. So remember, in this case, is more than 65. So we are going to use this formula because we want to know the normal distribution, and we are going to find the area that lies. Okay, so let me do this. I think it's much better with a graph. So we have our normal distribution, right? So this is my mu equal to 63. This is my sigma equal to 5. And the question is to find the area that lies to the right or 65. How do I know is to the right? So remember the sign, the peak is on this side. So I am gonna find the area that goes to the right. How do I find the area? Well, first of all, I have to find the area from this, and then I am gonna subtract 1 minus the area on the area on the left, right? Something that I can compute very easily. So I know that I can use this, but if I use 1 minus the formula, I'm gonna find the value automatically. So in this case, I'm gonna say equal, I'm gonna say 1 minus norm that this is asking me for the value of x, right? It's asking me for the mean, which is this 63, and it's asking me for the standard deviation. So in this case, the standard deviation is 5, and also asked me for the cumulative. Remember, the cumulative can be true or false. If we say true, we are looking at the cumulative area. If we say false, we are just looking at the value at that particular point. I don't want the value at this particular point. I want the cumulative area that goes from the beginning of the distribution up to 65 in this case. So I'm gonna say true, okay? So because I am computing the area and then I am subtracting from 1, so the area under the curve is gonna be 34, 457. So if I want to say this, there is a 34.46% chance that a person is going to score more, that person score higher than 65, right? So that's my response to this. So what is the likelihood? What is the probability that a person is going to get 65 and higher? Well, 34%, right? So in this case, we have the less than. So I'm going to use the first. So here, so what we are going to do is basically the following. Well, sorry. So before this, what we have here, so that's the beauty of this, or probably not the beauty. I don't know the C-score. I don't know the C-score. I know that this mu is equal to 0 with sigma 1. I don't know the C-score, but it's here. And the area to the right, so the area is going to be 34.46%, right? I can find the C-score very easily. So if I have this value, so we can find the C-score. I'm going to show you in a few more minutes. I don't want to be going back and forth. So I can show you that having this area and having mu and the standard deviation, we can find the value of x. So of course, I know that this is 65 because I was told that this is 65. That's how I compute the value. But so in this case, so I need the C-score here, right? So I don't know the C-score. So I can figure it out, but in order to find the area under the curve, is not that big problem. So I'm gonna use this. So in the second case, we have almost the same. In this case, we have a similar case. So we have a similar case. So we have an area under the curve. So my question is the area below 85, right? So I'm not writing this. So just keep in mind that these values are here. But now my x, my random variable, is 85. So the question is, what is the possibility that if I choose a person randomly, let's say I go to the cafeteria and I see all the students, and I will find a person whose score is going to be 85 and lower. So that means 85, 85, 84, 83, all the way down to 0. Of course, it's almost the class. It's going to be almost the complete class, right? So, so probably if I ask what is the probability that I find a person that is more than 85, so probably the probability is going to be very low. But anyways, here I'm going to use the first one because I'm going to measure the area under the curve, so I don't need to subtract anything. So in this case, I'm going to use the norm that dist is asking me for the for the variable, the random variable, who is going to be 85. The mean is going to be 63. The standard deviation is going to be 5. And remember, it's true because I want the cumulative area, right? So that is 99%. So what is the probability? So in this case, we can apply, it's like applying the, is greater than 85, right? So if I go to the cafeteria, how likely is that I'm gonna find a person with a higher score than 85? Well, so we can apply 1 minus this probability, and then that's gonna be a very small number. So remember, when we have these numbers, is because the number is, the scientific notation tells me that I have to move the decimal point 6 values to the left, right? So in this case, I'm gonna use the number, and probably it's gonna give me nothing, but if I keep adding values, so that's what we have. So the value is super small, right? So there is less than 100, 1,000. I mean, it's going to be very small probability, right? So so now we have this, and we can do the the area under the curve, right? So for this value greater than 85, the area under the curve is 85. Sorry. So this is the C-score that so far I don't know, but I can find it. So this area is going to be equal to 99.99%, right? So that's what we're going to realize. So the other case that we were mentioning, and I think is also part of the book, well, it's also part of the computation that we are going to do. Just imagine that we have the area under 2 different points, right? We have the area under 2 different points. So in this case, so we have our normal curve. Now that looks much better. So we have the mean that is equal to 63. And then we have sigma that is equal to 5. And I want to find the area under the curve between 65, let's see here, 65 and 85, right? So what is the probability that I am gonna go to the cafeteria, all my students are there, and I'm gonna find students who got between 65 and 85, right? So I want to know the probability. So I'm gonna transform this into my standardized normal distribution. So I'm gonna find the values for this and the values for this, right? So the goal is to find the area under the curve. So once again, here, I don't know the C-score. I can obtain it very easily, the C-score. So, so we are gonna do it later. So in order to find the area under the curve, so I'm gonna use the C-score for this, the C-score for this, find the area under the curve, and as I said, subtract the lowest from the highest. So let's do that. So in this case, remember, I'm gonna find the area under the curve to the left of 65, and I'm gonna find the area to the left of 85. And then I am going to subtract the lowest from the largest, okay? So I'm gonna use the standardized form, sorry. So I'm gonna use the norm that this command that we know. So the mean in this case is gonna be 65. So I can type it, or I can just click if I had the number typed in another cell. So the mean, we know that was 63. So let me do it by hand because I guess the values are higher up. So then we need the a standard deviation that was 5, and then the cumulative that is going to be true. So I'm going to find the area to the left of 65. I'm going to find the area to the left of 85. So it's going to be equal norm that dist. So I'm going to find the value. In this case, the x is going to be 85. 85. Once again, my mean is 63. My standard deviation is 5. So remember, those are the values, but they are typed on some other cells. And then the cumulative is going to be true, right? So I have the area to the left of 65. I have the area to the left of 85. All I have to do is to do the highest minus the lowest, okay? So that is the area. So this area under the curve. So I can express it like this, 0.344, or I can say this is 34.46%, right? So that's gonna be the case. So we have this area under the curve, okay? So so that's basically what we did here. So we have the norm dist and the 1 minus norm dist. So this is to find the area to the right and to the left. So so we find the probability that a random variable, a randomly selected student scored less than 85. I think there is a question over here. Same value as B6. I guess that was something casual. I don't know how that happened. I guess 34.5. This is less than 65. That's a very good question. That's a very good question. This is the, this is, yeah, because we are measuring, this is less than 65. Let's change the value. That's absolutely right. Let's change the value to avoid confusion. So let's say that here, so let me do the following. Thank you for noticing that. It's a very good point. So it might be confusing, I guess. So let's say that the values is between so let's say this is 60, right? So I am interested in finding values between 60 and 85. So the question is that this is the same value is because we are looking here at a value greater than 65. So we are looking to the right. So that makes sense when, well, I mean, it makes sense for me right now, but let's do 60 to avoid confusions. So let me do the following. So this 60 is going to be located, of course, to the left. So we're going to have 60 here. So we are going to have a C-score here that is going to be located here. So this is the second C-score. So the area that I want to compute is going to be here, right? Between C1 and C2, right? So let me change the value here. It's very easy. So I'm going to do, instead of 65, I'm going to say 60. So my probability should be way different, okay? So it was a little confusing. I saw the number and I'm happy who asked the question or who brought this to the attention, Terry, very good point. So here, my goal is to show the area under two different points. And if I use the same 65, probably I was kind of like giving a false sensation that the numbers are the same. So in this case, are the same because, so we were looking here at the, well, I don't know how it happened, but absolutely right. That was kind of weird. So, so in this case, the area under the curve is between 60 and 85. So if I go to the cafeteria and I ask for the probability of finding students between 60 and 85, so this number is going to be 75%. So here it should be between 60 and 85. So if you can correct it, please, please do so. And so far, there is a puzzle. What is this C-score? I don't know. I don't know. Can I know what is the C-score? Sure. So I have this information. I have an Excel code that I can transform this C-score, this probability into C-scores. Okay. So so let me continue with this. I think so. This is what we did. This is norm dist, and then the parameters that I need to consider. Also, this is very important, the K percentile. So let me see if I did here. Did I did it here? I think I did it here. So the K percentile, the K percentile, did I do it here? No, something is happening in my computer. Huh. So I didn't do here the K percentile. Let me see if I did it here. Okay, so this is the K percentile. So the idea of the K percentile is that you are going to be given a probability, and that probability is going to be what you are going to use to find the C-score. So in this case, if you have the probability, which is here called the percentile, you have the probability or the percentile, and you have mu and sigma, you can find well, this is the K-score, hold on. I'm getting ahead of this. So I want to know finding a random variable, or this is finding the probability, sorry. Sorry, this is the one. So I was getting confused. Just erase what I said. So we have the percentile, which is also basically, is also considered the area under the curve. For example, and I hope I didn't mess it up too much, we have here, we can have the area under the curve. For example, this is finding probability given a C-score. Hold on, I am still doing something wrong here. So let me follow the notes, because I guess I'm getting ahead of things. So we have the K percentile. So it's also like saying this is the, so the 90th percentile accounts for the following. So let me open. So I think I'm gonna do it this way much better. So sorry for the hesitation, but I was getting kind of entangled with this. So we have the following. So we have, the normal distribution, the standard normal distribution. So we have the 90th percentile, right? So the 90th percentile is almost like saying this area is 0.9000. You can find this number, this C-score in the, so you can find the, so here, find the 90th percentile. So the score K has 90% of the scores below K and 10% above K. So let's K be equal to the 90th percentile. So the variable K is located on the x-axis. So here we are, so we are looking for the area that is gonna be to the left. So in this case, the K variable often is called the critical variable, the critical value. So the 90th percentile is 69.4. So that means that the 90% of the test scores fall at or below 69.4. So what we're gonna do, basically, we have the area to the left, right? So this is the 90th percentile. So what we are gonna find, I think that's be more clear. So what we are gonna find is the X that falls here, right? So so we have the numbers, we have the mu, we have sigma, and then I'm gonna find the X value here. That's what this formula is gonna tell me. So the norm int, so we have these values, and I forgot to mention this. I guess I should follow what I already do. So we have these values. So we have these Excel. So we have these Excel codes that we can use. So in this case, this code, the norm inf, I need the percentile, mu, and sigma. That is basically is gonna tell me the following. So let me get this. So norm inf, so that's gonna be the one. So this is finding a random variable given a probability, right? So here the question is gonna be, I give you the probability, the area under the curve. So then you have to find the random variable. So that's what we ask here. So I give you the probability, you have a mu, and you have a sigma. Now give me this number, right? So we did it at the beginning here. So here is when we found the value of X. Ay, Dios mío, why it doesn't work? So we found here the value of X, right? So so we found that using this, if I have a mu, sigma, and the C-score, I can find the value, but also I can do it in Excel when I have this, what is my, so if I have the probability and I have the standard deviation and the mean, so basically this is what we are doing. So let me be more clear. Apologize for the hesitation. I don't know what happened. I prepared this class like ahead of time, and I have done it like 100 times. I don't know why I'm hesitating too much. So so here I have the mean, I have the standard deviation, and I am given the probability. So basically what I have here is the following. So I have my normal distribution, and I have my standard normal distribution, right? So I was told that this area accounts for the 90%, right? That is the 90th, the 90%. So because corresponds to the 90th percentile. So this point is gonna be 0.900. Remember, this is gonna be what is called the critical value. So any number that separates this area, the area to the left and the area to the right, is gonna be called the critical value. So in this case, the goal is to find X. So I have mu, which is 63. I have sigma, that is 5. So I need to find this value, right? So I'm gonna use this Excel code. So I'm gonna say equal norm dot dist. I am going to use the X. So in this, sorry. So I'm gonna say equal norm dot IMV. Now that looks much better. I'm gonna ask for the probability. So in this case, it's the 90th percentile. So then I am gonna introduce the mean, then the standard deviation, and I don't have to do anything else, right? So this value here is gonna be 69.4, right? 0.41. So that corresponds to the 90th percentile. So let me, I think I have another example somewhere in here. So those are some of the examples that you can do also in your assignment. So these cases are finding probabilities for the normal distribution. So let's see from the very beginning here. So what we can do, right? So let me start fresh. So if you encounter a problem, and I think that's what many people are afraid of. I think I started with the wrong foot today after taking my nap. So here, so we have the following information, right? So this is so let me, I don't know what's going on with my computer today. I guess it's like me sleeping. Okay. Cannot move my mouse. What's going on? So let me open another one. So what we're gonna do here, so we are gonna replicate the cases that we did in the first case, in the first place. Let me make it bigger. Zoom, 150. So in this case, what do we do, or what should we do when we have a problem? So first of all, of course, read the problem and identify the values that you need. So in this case, a survey indicates that people use their cellular phones an average of 1.5 years. So that word is telling me that is new. So it's 1.5 years, right? And the standard deviation of this is like a big data. Just imagine that all the cell phone companies are gathering information, like Samsung and Apple. They look at people's behavior and they realize that every year and a half, people change their phones, and the standard deviation is 0.25, right? So it's so this is 1 year and a half. This is 1/4 of a year. So 1 year and a half is the mean, and the standard deviation is 1/4 of the year. So so we can do. So the question is, a cellular phone user is selected at random. Find the probability that the user will use their current cell phone for less than 1 year. So my X here is gonna be less than 1 year, right? So I'm gonna put here 1. So what should I do? Well, very easy. So to find the probability that X is less than 1 year is gonna be the following. Remember, we did the norm dot dist. I open the parentheses. This is 1 year. The mean is 1.5. The standard deviation is going to be 0.25. And the cumulative, remember, is true. True because I want the cumulative area, right? So that's going to be the area under the curve. So that is going to be the following. So if we can draw this before, so we have this is my normal distribution when mu is equal to 1.5. So we have sigma that is equal to 0.25. And then I have the 1 that is here. So I'm gonna look for the area to the left of this, right? Because it's less than 1 year. So I found that this area is 0 0.0227, right? So this is almost the same as saying that it's a 2.27%. So if you were a company like Apple, would you create a new phone before 1 year? Well, probably not, because there is only 1 to 27% chances or chance that people are going to buy it, right? So, so this is based on this information. So that was very easy. So we can do another one. So this is the result. So in this case, we can make this smaller in number, the decimal points, right? So we have a second case that is going to be also interesting. So a survey indicates that for each trip to the supermarket, a shopper spends an average of 45 minutes. So let me copy this. I don't want to be creating these variables. So the mean is going to be 45 minutes. The standard deviation is 12 minutes. And then the length of time in the store is normally distributed, so we can apply the normal distribution. So find the probability that a shopper will be in the store for between 24 and 54 minutes. So here my X1 is going to be 24. My X2 is going to be 54, right? So I'm going to find the C-score, sorry, the probability that X1 is less than 24, and then find the probability that X2 is less than 54, right? So what is that? Well, because we have the case where we have an area under the curve that is situated between two different random variables. So this is my normal distribution, this is my mu, this is my sigma. I'm not putting the values. So, well, this is 45, right? So this 45, and this is 12. So I'm looking for 24. Of course, 24 is to the left of 45. So this is 24. And the area, the other critical value, that is 54, right? So what is the likelihood that this shopper is going to be in my store between 24 and 54 minutes, right? So I'm going to find the area under this curve. So what should I do? So remember, we have these values. Here, I'm going to use equal the norm that dist located between 24, comma, my mean is 45, comma, my standard deviation is 12, comma, and then true, right? So this is the value of 24, and the value of 54 is going to be equal to norm that dist. So the value of X is going to be 54. Then the mean, once again, 45, the standard deviation 12, and the value is true, right? So the probability that X is going to lie between 24 and 54 is going to be nothing else but I'm going to subtract the lowest from the highest. So I'm going to say the highest minus the lowest, right? So that's going to be my area under the curve, right? So I computed the area to the left of 24, computed the area to the left of 54, and then I used the difference to find the area under the curve. So here, what we have here is that, so we have this. So the area under the curve is going to be equal to 73%, right? So let me go back to this because I am already puzzled finding the C-score given a probability. So here I said before, we don't know the C-score, right? But I know the area under the curve to the left, and I know the area under the curve for 54. So what I'm gonna say, the C-score 1 is gonna be equal, hold on, what happened here? Oh, the C-score 1 is gonna be, I'm gonna apply this formula. So I need the probability, random variable, finding the C-score. I'm gonna use this formula, finding the C-score given a probability. I don't know the C-score here, but I have the probabilities associated to this. So I'm gonna use the norm. Why I cannot see this? Equal norm that IMV norm that S that IMV, and then I'm gonna type the probability, right? So the C-score here should be minus 175. So what I did is I used finding the C-score given a probability. I think I have it here. I don't know. I think was finding the C-score given a probability. We are going to continue to this. So in this case, as I said before, so where was my case? I don't know why I'm completely lost today. Where did I leave my? Oh, it's here. No, it was here. Sorry. So here, so I have the C-score. I use the finding C-score given the probability. So I have the probability. I have the area under the curve to the left. This is the area under the curve to the left of 54. So to find the second C-score, so I'm going to use equal norm that is that IMV. I am use the probability of the second, and that's going to be the C-score. So here the C-score that corresponds to this value, so is minus 1.75, and the C-score for the second is going to be 0.75. So let's try the second, the one that we didn't do before. So in this case, I was mentioning what did I do? So in this case, I think we found the area under the curve, right? So we have the area to the left of 60, we have the area to the left of 85. So I'm gonna use the same to find these C-scores, right? So I'm gonna say the C-score 1 in this case is gonna be the following, equal norm that is that IMV, and then the probability in this case is this one. I'm gonna do the second one, the C-score for 2 is gonna be equal norm that is that IMV, and then I'm gonna find the second one, right? And that is the C-score, right? So these two C-scores are gonna be right here. So C-score 1 is minus and 0.06 minus 0.6. That means that this number is located 0.6 standard deviations to the left. And this value is located 4.4 standard deviations to the right. So that basically is telling me that 85 might be a very unusual number, okay? So is this clear so far? Guys, are you still there?
Yes.
Yes.
Sorry
Yep.
for the back and
Yes.
forth, but just try to follow these formulas. Those are very, very helpful. I can tell you, very, very helpful. So let me revise these cases because those are the numbers that we're going to use. So finding the C-score given a probability. So we have the Excel function that is norm s.inf. So this is the probability. And remember, this is the area to the left, right? So when I am using this formula and is the area to the left, all I have to do is use the formula norm.s.inv, for the probability here, and then that's going to be the value. So that's going to be the C-score. So let me, so let's say that we have this. So the area under the curve is going to be this, right? And this area is going to be this value. So the C-score is going to be this value, right? Is minus 34.5 minus 34.5 standard deviations to the left, right? Less than 1 standard deviation to the left. So we have another example here. So we have another example. In this case, we have the area that is the top 75%. So like, for example, if you are doing a test and the requirements is that you have to be among the top 10.75%. So that basically means the following. So we are expecting that your score follows within this thing, right? So you are on top of the 10.75%, right? So that basically means that this area represents the 0.1075, right? So by definition, the other part is 1 minus 0.1075. So what we're going to do here, and that's the reason I use this notation. For example, I can do exactly the same, right? So I'm going to do equal norm that is that IMV. I am going to use this for this area, and I'm going to say enter. So what do I have here? Because the value is greater than my C-score is minus 1.23. So that is not correct, because if I have the greater than, that means that the C-score here is going to be equal to 1.24, let's say, right? So this value gives you the area on the left, right? So this is, so this area here, if I am, well, just forget. So if I have the 0.1075 to the left, right? So that means that this is the area under the curve. That should be the C-score. But remember, this is symmetric. The same area here, and if I have the same area on the other side, so it makes sense that if this number is negative, so the symmetric for the positive is going to be exactly the same number, but with a positive number. right? Is this clear for everybody? So here the idea is that you can use the same norm as that IMV and then the probability for both the positive and the negative. So if I am using here the greater than, so of course the C score on the other side, so it's going to be a positive number, right? In this case, is the less than, here is the more than. So here, there is another example. So let me do this. So this is the 10%, greater than 10% is exactly the same idea. So the probability of, so in this case is greater than the top 10%, right? So I forgot to say this is the top. That means that this on the other side. So greater than 10%. So here, let's say that this is the 10%. So this area is the 0.10000. So here the C score. So in this case is not the top. I'm looking at the area to here, but I don't care too much because in this case, the area that is greater than this number, basically what I am interested is in looking for this C score. So in this case, the idea is that you are looking to the area to the right, basically the top performers, right? So so I think this is going to be a little bit confusing. Let me make so let's say less than the 10%. So I guess that will make more sense, I guess. Less than the 10%. So this is the 10%. I'm not looking for the area to the right, but I'm looking to the area to the left. So the score here basically is going to be equal to the norm, that is that IMV, and then the probability, right? So if the score was the top 10%, so I didn't say that. That's the reason I changed this. So even if it's the high greater than 10%, so what I'm interested is in the C score. For example, in this case, if I have the top 10%, you are measuring scores. So here in this case, with this is you are looking for the lowest 10%. The top 10% is going to be on the other side. Of course, the C score in this case is going to be the same, but with a positive number. Okay. I hope it's clear. I hope it's clear. So just look at these cases. If you are looking for the top, this case is more clear if you are using the less than, because you are looking for the area to the left. So that makes sense that this C score is going to be here, right? So if I am looking for the top 10%, of course, that's the other case. So so we have also to complete this class, I guess we're running. I don't know why I cannot move my. So here we already did this, finding a random variable given a probability. So we have the probability, we can find the value of the random variable. Here we have finding a probability given a C score. So in this case, I have a C score. So so that's one that we did before too. So so here we have a C score that is minus. So in this case, the C score is equal to minus 2.33. So the question is, what is the probability that lies here? Well, that's going to be easy because we are going to use Excel norm that is that dist, and then we are going to use the value of the C score, right? too many, oh, and true, okay. So, comma, and true. So the area under the curve is gonna be almost like 0.9%, right? So, so let's say that we have another case where we have a C-score where the score is 2.33, right? So this is the value on the right. So what is the cumulative area? So what is the area under the curve? So in this case, I'm gonna do the following. The probability of X, that is, or the probability of the C-score. So the C-score is gonna be equal to 2.33. So I'm looking at the other side, right? So I'm gonna look at the area under the curve, which is gonna be equal to norm dot s dot dist, and then the value of my C-score, and then true, right? So the area under the curve here is gonna be 99%, right? So of course, if I'm looking for the area to the right, so then it's gonna be to the right of the C-score is gonna be 1 minus this value, okay? So I hope this is clear. I think that's all that I want to say today. So all these cases that we were looking at today, so so you can easily replicate them using the Excel functions that I gave you. So very easily, we have to identify the values. For example, in this case, I need the mu, I need the standard deviation, and I need to know the values that I want to compute, whether the values are to the left, are to the right, or are between two different points. Something that I didn't mention is this case, if 200 shoppers enter the store, how many shoppers would you expect to be in the store between 25 and 54 minutes? So here, we already computed the value at 73%. If 200 people are entering the store and there is a 73.3% chance, so I'm gonna multiply the probability times the sample size. So I might expect that about 147 shoppers are gonna be in my store between 24 and 54 minutes. So there is not random that companies are arranging spaces in supermarket according to the time people spend. Of course, you want to buy milk, so you don't see the milk at the beginning of the store. At the end, you find the milk, but you pass by the cereals, you pass by the popcorn, you pass by all these nice aisles that have different food that you probably don't want to spend. But I mean, that's gonna be something that a manager wants to know, right? So find the probability that the shopper in the store will be more than 39 minutes. So that is the area to the right. So we can compute it very easily with our 1 minus norm that dist, and then the x, the mu, and sigma, and true. So we can do that very easily. So I show you how to find the C-score that corresponds to our cumulative area. So you use the norm.s.inv and then the probability. So you have the probability, you're gonna find the value of the C-score. So this is using the tables. You are welcome to use the table. If you have the probability, so you just have to identify the probability that closely matches the C-score. So in this case, 0.3632, which is the 36.32%, is exactly a minus 0.35 standard deviations to the left. So you can do it by using the table, or you can use Excel and just find the area, the C-score that corresponds to this area under the curve. So we have another example. This is the one that we did, the top 10.75%. So so that was the way it was computed. So so in this case, what they did is you don't know the area to the right, but you know the area to the left. So in this case, you can find the area that lies to the left, and that's going to be the value of the C-score. So we use that nice code for Excel. So that was very easy. So so we have this example. So this in this case, the case that I was trying to make here is based on a top 10%, but I didn't say that. So that's the reason I was kind of confused. But in this case, if you have the top 10%, so in this case, you're going to hire those who are scoring on the top 10%. So the area to the left is going to be the 90th percentile. So we can compute this using our score 2 because as I said before, we're going to find the area to the left. So so this is the C-score that lies to the left. But if I know that this is the top 10%, so that means that it's on the other side. So I am going to be interested in the area to the right. So I can find it very easily by using the same area under the curve, but I'm going to change the value when I have this greater than, right? So I'm interested in finding the best of the best. So I'm going to hire those who scored 10% and above. So that's the C-score. Also, we found out how to find the X when we have mu, we have the C-score and sigma. So we can just multiply these values and find the area, the value for X. So in this case, the value for X is going to be 62.8%, having a C-score of 128, and then a mean and a standard deviation that was known at this point. So that's, I think that's it for today. I hope this is just try to revise these ideas. As I said before, this is a very good way to go back and forth. So if you need something, you just see what you need. If you want to find the area to the right, if you want to find the C-score with your data, you want to find the probability to the left, the probability to the right, or the probability between two random variables. We also have finding the probability given a C-score. So if I have the C-score and I want to find the probability, this is the formula. Finding the random variable given a probability. So in this case, I don't have the C-score, I just have the probability. So I'm gonna, if I know the mean and the standard deviation, I can find the value of X. And finally, finding the C-score given a probability, I know the area under the curve. So I'm gonna find the C-score that divides, that is called also in this case, the critical value, right? So I think that's it. Does anybody have any question? Any questions? Any question?